Hello guys, let us start our review with the longest problem. Consider the given preference table, find the winner of the election using 4 different methods. If you have started the review assignment, you have noticed that we will ask you to apply all 4 methods that we have started in the course. The first of them, the simplest one, is plurality method. In this method, we consider only the first row of the table, so that only the first place on the ballots. So the candidate A gets 31 vote, candidate B 20, candidate C gets 15 votes, and candidate D, the last one, let us look. In the first line, D has 28 votes. So the largest number among these 4 is 31. So candidate 8 wins the election with plurality method with 31 votes. The second method is plurality with elimination. We start on the same way, considering the first row of the table, and then we eliminate the weakest candidate until one of the candidates gets the majority. The majority is a half of the votes plus 1, so the number of votes that is greater than the half. Let us add all voters. 31 plus 28 plus 20 plus 15, 94. The half of this, 94 over 2, will be 47. So the majority will be one more. 47 plus 1, 48. So we will eliminate the weakest candidate until we get the number of votes greater than 48. So on the first step, we get the same as in the part A, and we eliminate the weakest candidates, which is C. So we can draw the table without C. So moving all candidates that below C in each column 1 row up, or we can do the following: A, B, C, D. When we remove C with these 15 votes, then this 15 votes go to the candidate that is next in this column, goes to B. So B has 20 plus 15, 35 votes. It is greater than A or D, but it is still not a majority of votes. So we need to remove the next weakest candidate. So we have 31, 35, and 28. 28 is the lowest number. We remove D from the table and look at the table. When we remove D from the table, then it's 28 votes go to B. So B gets another 28. So 63 vote, and now we see that B is the winner of the election according to plurality with elimination method. Let us consider the border count method. So in this method, we assign each vote for the number of points. For the first place, we assign 4 points. For the second place, 3 points, 2 points, and for the last place, 1 point. And we add the points. Let us start with A. A has 31 ballots with the first place. So 31 times 4 points for first places. Then it has 15 third places. 15 times 2. We assign 2 points for the second place. For the third place, sorry, for the second from the end. And 1 point for the last place. And there are 28 plus 20, 48 ballots with 1 point. 202 points. Candidate B. The candidate has 20 first places, 20 times 4, then 28 plus 15 second places, so plus 28 times 3 and plus 15 times 3, and it has 31 third places. 31 times 2, 271 points. Candidate C. First place is 15. 15 times 4. Second place is 20. 20 times 3. Next line, 28. 28 times 2. Plus the next line, 31. 31 times 1. And this equal 207. And the last candidate, D. So D has 28 first places, 28 times 4, plus 31 second place, 31 times 3, plus 20 times 2, and plus 15 times 1. And this is 260 points. The largest number is 271. So according to border count method, the winner of the election is also B. So, and the last method is the pairwise comparison method. I will use this place here. So to see the table, we should compare all possible pairs. So we have 4 candidates. We compare A and B, A and C, A and D, B and C, B and D, and the last pair will be C and D. So 6 pairs, 6 possible pairs. And we decide who wins in this pair, who has more votes, A or B. So we consider each series of ballots and count how many times is A above B and how many times is B above A. So on the first ballot, we have A above B on the first series of ballots, on 31 ballots. Then on the second group, B over A, B over A, B over A. So A over B is on 31 ballot, and on the rest is B over A. So definitely B has more votes. So let us write one more time A, B, C, and D, and count the wins, so to say. So this time B wins over A. We add 1 point to B. Now let us compare A and C. A is above C in the first column, then on the second C above A, and C above. The same situation. So A is above C only on 31 ballot. All the rest, we don't need exactly the sum, is C above A, so C wins over A. The next pair, A and D. A is over D, again, in the first group, 31, and then D is over A. Okay, so here we have a different situation. A is over D on 31 ballots and on 15 ballots. 31 plus 15, 40 on 46 ballots. And D is over A on 28 plus 20 on 48 ballots. So D is above A, and D wins and gets another point. So gets a point. B and C. B above C here, here, and here. C over B only in the last group. So C wins on 15 ballots, and it is definitely less than the other three groups. So B wins. B gets a point. B and D. B and D. So D wins in the first group and in the second group, and B wins in the third and in the fourth. So let us count the points. The ballots on 31 plus 28, 59 ballots. D wins over B, and B wins on 20 plus 15 on 35 ballots. So D wins in this comparison. And the last group, C and D. D is above C on the first, on the second group. So 50, 59 for D. And C is above D on 35. 35 for C. D wins one more time. So you see that by pairwise comparison method, D is the winner. So we got three different winners. A wins by plurality method, B wins by plurality with elimination and by border count, and D wins by pairwise comparison method. So only one candidate, C, never wins. So all the other candidates have at least one chance to win the election, depending on which method will be used by counting ballots. Let us consider the following weighted voting system. So we have quarter Q and 4 voters. The voter with the weight 5, the voter A with the weight 8, not given, and the voter with weight 8 and 1. So suppose that A is 4. Which value of Q would give all voters a veto power? So what does it mean? So it means that if at least one voter in this system doesn't vote, then the resolution is not possible. So it means that the sum of votes of these 4 voters must be equal to Q. So we have 5 plus A is 4, plus 4 plus 8 plus 1, the sum is 18. It means that Q must be equal to 18. In this case, all voters must vote to pass the resolution, any resolution. Suppose that Q quarter is 20. What is the minimum value of A that would make resolution passive? So this similar situation, without A, we have 5 plus 8 plus 1. This is 14 votes, and we need 20. So what should we add to the system to get 20? We should add 6. Then the total sum of all votes will be 20, will be equal to the quarter, and altogether they can pass the resolution. So A must be equal to 6. Suppose that Q is 15. What is the minimum value of A that would make the voter A become a dictator? So dictator can pass any resolution alone and nobody else. So it means to be able to pass the resolution, this voter have to have at least 15 votes. So A must be equal to 15. Then this voter can pass any resolution, and the other voters together so have only 14 votes. They cannot pass any resolution without A. So this voter is a dictator. 2 dice are rolled. Find the probability that neither die shows 1, and what is the probability of getting a sum less than 9? So 2 different questions. For both of them, we need to draw a table of all possible situations. So we have 6 outcomes or 6 possible numbers that the first die can show 1, 2, 3, 4, 5, or 6, the same for the second die. So we talk about the sum here. So let us write the sum for every combination. When the first die shows 1, the second shows 1, the sum is 2. So 1 and 2, 3. So, and the second row, if the first die shows 1, the second 2, the sum is 3, here the sum is 4, and so on. Now let us consider the first question. Find the probability that neither die shows 1. In the first line, the second die shows 1, the first die shows 1, 2, 3, 4, 5, 6. So we have 6 outcomes here. In the first column, first die shows 1 and the second shows 1, 2, 3, 4, 5, 4, 6. So altogether we have 6 plus 5, 11 outcomes with 1. So be careful, don't count this outcome 1, 1, 2 times. So we have 6, 6, and this is counted twice altogether. They are not 12, but 11 outcomes. But the question is the probability that neither die shows 1. So we are interested actually in all other outcomes. You can count them directly, or you can subtract from 36. So you can do both. You can find a complement of the event, the probability of at least one is the probability of 1 is 11 over 36. So the probability of no one can be found by subtracting from the probability of a sample space from 1 minus 11 over 36. We can represent 1 as 36 over 36. Then we have the same denominator, and in this fraction, in the numerator, we have 36 minus 11, 25 over 36 is the probability of neither die shows 1, or you can count them. You will find that it's the same 25 divided by the sample number of outcomes in the sample space divided by 36. So the probability is 25 over 36. Let us answer the second question. What is the probability of getting a sum that is less than 9? So the sum is equal to 9 on this length line. It is greater than 9 below this line and less than 9 above this line. So, and again, you can either count all these outcomes or use the probability of a complement of event, probability of less than 9 will be 1 minus probability of greater than or equal to 9. 1 minus probability of greater than or equal to 9 will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 outcomes with greater than or equal to 9 divided by the sample space, 36, the number of outcomes in the sample space. And we do the same. We represent 1 as 36 over 36 minus 10 over 36. Write this with the same denominator, 36. We have in the numerator 36 minus 10. So 26 over 36, and both numbers are divisible by 2. We divide by 2 and get 13 over 18. The probability of getting a sum less than 9. The next problem, we consider the game of chance, and we draw a card from a standard card deck. We pay $5 to play the game, and then we will calculate the expected value of this game. So we will add probabilities times the value of this outcome. So we have several situations. If you draw a face card, we have 3 face card, or so we have 3 face card, the probability will be 3. So 3 times 4, 12. From 50 to 3 suits, 4 suits with 3 face cards in each of them. So 12 face cards divided by total number of cards. 12 over 52 is the probability of getting a face card. and we must multiply probability and the value. And in this situation, we win $10. $10 win. And don't forget to subtract the cost of the game. Subtract 5. So we multiply by 10 minus 5. Second situation, 2, 3, or 4. So, and this is again 3 different cards, 3, 2, or 4 in 4 different suits. Again, we have 3 over 4 from 52, and the value of this outcome, you win $3. Win 3, subtract 5 that you paid for the game. You draw 5, 6, or 7. Again, 3 outcomes from every suit times 4 over 52. You could actually consider 3 over 13, since 4 over 52 will be 1 over 13. It's not important. So then we win nothing. So you get nothing, again 0, but you pay $5. If you draw 8, 9, or 10, then you lose $1. Again, we have 3 different cards and 4 suits from 52 cards. Then you lose $1. Minus 1 and minus 5 to play the game. So to find the expected value of the game, we must add these 4 outcomes. So 12 over 52 times 5 plus 12 over 52 times negative 2 plus 12 over 52 times negative 5 and plus 12 over 52 times negative 6. So the game looks to be very unfair. Can factor out 12 over 52, and in parentheses we have 5 minus 2 minus 5 minus 6. 12 over 52 will be 3 over 13, and here we have negative times negative 8. So negative 24 over 13, or approximately negative $1.85. So almost $2 lost will be lost on the average when you play such a game. So here be careful, read good the problem, so it will be given how many places after the point you should give in your answer. There will be one problem in the exam for using the formula for the probability of the union of the events. So union is the same as or of 2 events. If you know that, for example, the probability of A or B is 85% or 0.85, probability of A is 0.70, and probability of B is, for example, 0.22, then you can find probability of A and B. A and B, of intersection of these two events, A and B, or the situation where A and B are occur simultaneously. So we should solve such an equation for this unknown. So thus we can add these two probabilities. 0.85 equals minus 0.92 minus probability of A and B. So to find this P, we can, for example, subtract 0.92 from the left and from the right. We'll get negative 0.07 equals negative probability of intersection A and B multiplied by -1, then probability of A and B equals 0.07. Let us find the mean, median, range, and standard deviation for the given data set. So to find the mean, we add all the numbers from the set. So it's plus 12, plus 25, plus and so on, plus 30, and divide by the number of these numbers. How many numbers we have in the set? We have 8 numbers, so we divide by 8. 174 over 8 equals 21.75. This is the mean of the set. To find the median, we first need to order the numbers. So here be careful, don't forget any number. So, and here also, it is important that you don't skip any numbers because you will need this mean to find the standard deviation. So, first 5, then 12, then the next 16, the next, oh, we have 3 times 20, 25. Then we have 30 and 36. We still have 8 numbers. So the median, if we have the even number of outcomes here, then we should find the mean for this number. So generally we will have to add these two numbers and to divide them by 2. This time the symbol is just 25, so the median is 25. The next we have to find the range of the set, and since we have the numbers arranged here, we just subtract the greatest number minus the smallest number, and the range will be 36 minus 5, it is 31. And the most difficult part is the standard deviation. So we have to subtract the mean 21.75 from each of the numbers. 36 minus 21.75, 12 minus 21.75, 25 minus 21.75. So we are lucky here we have 3 times, so we can multiply this by 3. So then we have 16 minus 21.75, 5 minus 21.75, and 30 minus 21.75. Let's see, haven't forgotten somebody. So then we square each difference. square. In this case, we first square, then multiply by 3. Square, and then we add these numbers. Then we add these squares. The sum is 711.5003. Then we divide by n minus 1. We have n numbers here, we divide by 8 numbers here, we divide by 8 minus 1. 711.5003 we divide by 8 minus 1 by 7, and then we take the square root of this number, and it is 10.0818, so on. Then we look what is asked in the problem, how many points after the digits after the point we should take, and we round. Suppose that we have to round to 2 decimal places. It means we take 0 and 8 after the point. 10.08, the standard deviation. The next problem, we have a normal distribution with a mean mu equal 54, standard deviation sigma equals 12. Consider the scores that were contained by the middle 68% of the set. So for the normal distribution, we have a distribution in this bell form, and we have a special rule 68, 95, 99.7 rule. If we have the mean in the middle of this normal distribution set, then 68% of the values are within one standard deviation, so one sigma to the right, one sigma to the left of the data set. So 68% will be between mu minus sigma and mu plus sigma. So if we have, for example, 95%, then it will be between mu minus 2 sigma to till mu plus 2 sigma. In this example, we have 1 sigma. So the question is, which is the z-score correspond to the lower end of this 68% range? The z-score is, so to say, the coordinate of this point in terms of standard deviation. So how many standard deviation from mu? So the left end is 1 standard deviation from mu to the left, so z equals -1. Which z-score correspond to the upper end of this range. So this is the upper end of this range, and this is 1 standard deviation from the mean. So z-score is +1. Find the raw score associated with the z-score from the part A. We have a formula connecting z-score and raw score for the normal distribution set, and so the mu and sigma, we can substitute them. So z-score for in the part A is -1. X we want to find. Mu is 54 and sigma is 12. We have to solve this equation for x. So we multiply by 12. Negative 12 equals x minus 54. And we add 54 to the left and to the right. And we get x equals to 54 minus 12, 42. This is the x score on the left, this point. And the second situation, the upper end, z score is 1, the rest is the same. 1 equals x minus 54 over 12. And we solve in the same way. We multiply by 12 by the denominator. We get the equation without fractions, so 12 on the left and x minus 54 on the right. Then we add 54 to the left and to the right and get x on the right equals 66. 66 is the row score on the right end of the 68% interval. Another interesting problem, it's very simple. We just have to construct a histogram for this data set. So we will divide these numbers into 5 classes with a uniform class width of 10 points, using the lower limit of 10 points for the first class. So the first class starts with 0, then the width is 10, so it will be 10, 20, 30, 40, and 50. So let us count how many numbers will fall in each of these classes. So it is very simple. We just take the number and put it into one of the classes. So the first 20 goes to this class. Oh, there's not 75, 25, 25, the same one. 24, also this class. 25 again. 28, then 35, 47, 36, 12, 25, 16, 25, 25, 5, 30, 42, 36, 33, 32, 24, 16, so the first row is done. 41, 39, 37, 16, 46, 42, 21, 31, 28, 27, 23, 20, 35, 24, 25, 28, 35, 17, 26, 22, 35, 16, 45, 25, another 5, 30, 42, 26, 33, 32, 14, 6, 11, so 19 also falls in the second class, 37, 16, 42, 34, then 21, 11, 18, 27, and 19. So we can, so it actually looks very good like this. We can draw it a little bit better. So it look better with this. So not too accurate. So we have this 5 classes, 10, 20, 30, 40, 50. So in the first class we have 3, in the second 13, in the third class 23, in the third class 17, and in the last class we have 8. So we can make such a histogram. We need 25, 10, 20, 11, 20, 25. So in the first class we have 3. This is 3. In the second 13. In the third 23. Three, 13, 23, then 17, and last class is 8. So this is a wonderful histogram for the graph for this data set. So if you have any question, you can always call me on ask for an appointment with the Zoom, or send me an email and ask your question. If you have trouble with solving a problem from the review, you can email me or your what you have done for the problem, and then I can quickly tell you what is the next step, or what was the mistake, or what can be done here. If you have any other problems, you can always email or call and ask your question. If you will have some problem during the exam, you can always call during the exam. That's not a problem, and or email. So I usually always available on the day of the exam. I wish you good luck and thank you.